Okay, in this section, we are going to talk about the discrete input-output models. We mentioned that we have two types of input-output modules. One is discrete and the other is analog. And the difference between the discrete and analog is depends on the type of the device that can be connected to these interfaces. So, for example, as you can see here in the figure or in this component shown in the slides. So we have here, this is the type of the discrete input modules or discrete output modules, and it can show you what are the type of the device that can be discrete with the input modules and what type of the output devices can be connected with the output modules. So you can see here the component that can be disconnected to the discrete should be a discrete component. That means it has only two options or two status, either on or off, 0 or 1. So for example, here we have push buttons, we have selector switch, we have limit switch, we have proximity switch, and all these type of devices or input devices are discrete. So their output, it should be either 0 or 1, no other options. Okay, for the output devices, here we can see indicator here, indicator light or signaling column, relays or motor starter and so on. So this type of discrete input output modules, it will be used with this specific type of devices which has discrete values, either input or output. Okay. Actually, the discrete input-output models usually powered by the power supply from the power supply modules or power supply unit, which is attached to the PLC. And different modules, it has different rated of voltage and current, so it can be some of operating using AC, some using DC, and it start from, for example, 12-volt AC or DC until 24. There is some which work with 48, 120, 230, and so on. This is for the input interface modules, and for the output interface modules, actually it's that also same 12, 120 to 30 and so on. Actually, it depends on what is the type of the modules and how big is these modules, and so it can be operated either by DC or AC voltage, which is power from the power supply of the PLC unit. This we already see before, how we can plug in the unit or the interface modules here inside the rack of the PLC, and we can see here the backplane power. So from these ports, actually this port we are going to, it will going to provide, or it will provide the power to the modules, either for the discrete or for the different modules. The power, actually, when we plug these modules inside this rack, so it will be connected through these ports, so the power will go through to the device or to the electronic circuitry of these modules to switch it on or off. So this is how is the block diagram of the discrete input model looks like. So since we have a discrete input model, that means its input will come from the input devices or discrete input devices like switch or sensor and so on, as we mentioned before. So for the power circuit of these models, actually, this when we call it the interface or input discrete input module interface or discrete output module interface, that means it will split or it will be interface between the field devices and the controller. So these are the circuits that will be existing or to connect the module or the interface, the input interface. For example, here we are talking about the input, so it will connect to the input interface into the microcontroller. So it starts from the power supply, which is 120 volt, for example, AC here. If it's 120 volt AC here, it need to be converted into DC. If it is DC, so no need to convert, so just use. For that, is since it is in AC here, it will be converted into DC here. We have a bridge rectifier, as you studied before. When you use the bridge rectifier here in the electric machine course, I mean in the electrical power system course, this rectifier will be convert the AC into DC. Okay, then after that, the signal will be moved from the rectifier here, or from the bridge. Here we already have a DC signal at this point. So this DC signal will go through the Zener diode, and this Zener diode here used as a protection actually. Like we mentioned before in the chapter 2 about when we talk about the signal conditioning circuit, we mentioned Zener diode is one of the protection or isolation circuit. Okay, and here we have also opto detect electrical isolation. Also, it's used to isolate between the electrical part. This we call it the electrical part of the circuit, and the logical part. This is the logical part. The logical part actually is more on the circuit which is go to the electrical part, or the logical part is the part which is before the controller. So we said the input interface here is interface between input devices at this side and controller on the other side. So it will receive the signal from the device like sensor switch, then it will pass these signals to the microcontroller. Okay, so we can see here it is isolate or totally isolated from the microcontroller. As we mentioned before, the microcontroller is the most expensive part of PLC system. For that, in order to protect the PLC controller or the microprocessor unit, we use this optoelectrical isolation. So all this circuit is isolated from the other circuit. And this indicator actually it will indicate the status of the input. Is it on or off? As we mentioned before, sensor number 1 is on, sensor number 2 is off, and so on. Or switch number 1, switch number 2. This is the discrete input model schematic diagram in details. It's the same as the block diagram, but in this case here it show you in the details about the, for example, here we have the AC circuit in this side. Then we have the go through the bridge or rectifier here. This bridge consists of 4 diodes to convert the current from AC to DC. Then we have here the Zener diode for the regulating the voltage, okay, for threshold of and detecting the threshold value. Then we have the optical isolator in this part, which isolate the electrical circuit here and logical circuit on the other side, or control circuit on the other side. When this circuit actually for optical here, as we study in chapter 2 how the optical isolator is work, when the signal is come to this diode, light emitting diode, it will send the signal to the other side. The other signal side will receive, or the receiver of the optical isolator will receive the signal, then it will pass it through the digital logic circuit here, and this LED indicator will show that it's on or off. Actually, as we can see here, several signal conditioning circuit are placed on the discrete input and discrete output models, either discrete or analog, both of them. But since we are talking now about the discrete, so we can see here the signal conditioning circuit are placed. We have some type for protection, some type for preparing the signal to be suitable to read by the controller, and so on. So we can see the discrete input modules here perform 4 main tasks. Okay, these are the 4 main tasks that carried out by the discrete input modules or discrete out, or analog input modules later on. Okay, the first is sense when the signal is received from the field device. When we say field devices, that means either sensor or switches. Then convert. See, it is convert the input signal to the correct voltage level, okay, for the particular PLC. For example, here we have some type of the amplifier, like we study in signal conditioning circuit in chapter 2. Say if the voltage is low, it will make the voltage is at acceptable level, it will increase. If the signal is analog, it will convert it into digital. If the signal is digital, it will convert it to analog, and so on. Okay, then isolate the PLC from the function, the fluctuations in the input signal. So how to isolate? It use several protection circuit like the Zener diode, the optical electrical isolation circuit, and also it used the bridge to convert the signal, which is like to convert it from AC to DC, and so on. Okay, then send the signal to the processor indicating which sensor originated the signal. When we say send the signal to the processor, since the discrete input will receive the signal from many sensors, maybe 100, maybe 1,000 of sensors or switches. So each sensor, it has its own address. So this address will be known because it's connected to specific terminal in the discrete input module. For that, the controller can understand, yes, I received this signal from sensor number 1, I received that signal from sensor number 50, for example. Okay, so these are the main 4 tasks for the discrete input modules for the PLC system. For the discrete output modules, it's just the same task, but it will be on the output side, since it is will be placed after the microcontroller or after the microprocessor unit. Okay, so, this circuit or these modules will be interface between the microcontroller and actuators, which is represent the output devices here. Okay, the circuit here, since we start at the microcontroller at this place, so this side we call it the logic side, because the signal here is logic, come from the microcontroller, either 0 or 1. Then we said if we can use, or if we have output or a device which is digital output or discrete, we can use the signal that we receive from the controller directly to the output device. But if we have the output device is analog device, so we should convert this signal into digital to be sent to the output device. So we can see from this block diagram, the signal come from the controller at this point, it's go to the logical circuit here, and here is the indicator for the output device. Is it on or off? The signal come from the controller to switch it on or to switch it off. Since it is discrete, there is no other options. Then we have the optoelectrical isolation circuit here to isolate between the logical part and the power part of our circuit. This optical or optoelectrical isolation circuit will send the signal to electronic switch. Why electronic switch? Because we want to switch on or switch off the output load or the output device. No other option, only discrete, either 0 or 1. So in order to go 0 and 1, we need to use electronic switch devices. Okay, and then this will be sent to the output devices. We can see here the schematic diagram of our discrete output modules. So it's come signal from controller, go through the digital logic circuit, go through optical isolator. Then we have the switching circuit here. So the switching circuit here, it can be used to switch on off the or it will be used to switch on and off the output load, but it depends on the type of the signal that we are going to switch on and off. If we have a signal is DC or AC, so it will be depends. So the type of this electronic switch will be changed. As we will see here, we have three types actually of the output devices. The first type, we call it, we have three types of the output device for switching or the electronic switch. One type we call it the relay. As we already know before, we said the PLC actually is developed based on the relay control based. So the relay here can be used with the AC or with the DC also. At the same, I mean, either we want to control AC circuit or DC circuit, we can use the relay. Since the relay, it has coil and it has contacts, so the coil will be fed from the electrical circuit of the output of our microcontroller. Then the contacts will be used to control our circuit, which is connected on this place, either AC and DC. If we want to control our load is a pure AC, that means we are sure that's AC load, so we can use the triac here. So the triac in this point here, we can see this is the triac. It looks like it's one of the, actually the triac we already mentioned before in the EPS course, in the power electronic part. Okay, so this triac used to regulate the output AC voltage. Okay, so here we are going to use it to switch on, switch off the output AC load. The third type of the load can be is the DC load. So we are going to use a transistor. Okay, also transistor we already have in the power electronic part of the APS course. Okay, so the transistor here will use for DC, the triac will use for AC, the relay will be used for AC and DC at the same. We go back to this circuit here, where individual AC output here are usually limited to the size of the triac. That means it depends. If I want to connect to the small load, so if the triac is only 1 ampere, so just it's okay. 2 ampere up to ampere, it's okay. But if I want to control for higher load, so I should go to use the relay. So the relay is more flexible in the rating. So you can control small load or big load. But if I want to use the triac, so I have limitation in terms of the rating value of the current here. So as we can see here, the output circuit or the output modules here interface will be connected to the coil of the relay. And from this coil of the relay can be energized or de-energized based on the output signal. If the output signal is on, I mean 1, so this will be energized. If the output signal is 0, so this will be de-energized. In the case of energized or de-energized, this coil will be changed. The status of this coil will be switch on or switch off. If it's switch on, the motor will be run. If it's switch off, the motor will be stopped. Okay. So here also this actually not the real motor. The real motor is here, but here is the coil or the starter of the motor. In this area, we have the starter of the motor. So the starter of the motor will be used to switch on or switch off the real motor on the other side. There is some actually there is one important concept we use with the discrete input output modules here. We call it the syncing or the current sourcing or current syncing. So we need to differentiate between two type of the modules and sensors. Okay. So in the first type, we call it if the model is current sourcing modules, then input or output device must be current syncing. Sourcing means this we have the syncing input module. This is the syncing input syncing, and here we have sourcing input module. This is two type of input modules for the discrete types. So if the module is syncing, the sensor must be sourcing. What we mean by sourcing? That means the sensor will send the voltage, or I mean will send the current to the modules. The sensor will take the power from the supply and send it to the module. So the power or the current will flow from the sensor to the module. So the sensor we call it the source, and the module we call it the sink. In the other type, we have the power. Actually, you can see here the power go from the supply. This is the positive terminal. Usually the power go from the positive, or the current go from the positive terminal, go directly to the module here, and the return from the module will go to the syncing sensor. So for that, we call this module is sourcing and the sensor is syncing. I cannot use syncing with syncing, sourcing with sourcing. It must be one of them source, one of them is sync. Okay. So this is the case of the in the case of the output devices. Here in the previous slide, this is related to the input device. Okay, and for the output device here also the same is the output device. That means the sourcing will go from the module here, go through the syncing device and the power supply and return. And for the syncing module is the go from the power supply, go to the sourcing sensor device, I mean actuator, and then go to the module. The different here this device is represent actuator because we are talking about the output modules, and on the previous slide we are talking about the sensor devices. We continue in the next video.